Hey everyone, today we're going to talk about the sampling distribution of the sample means. So basically our focus of our study would be about the population and the sample. So when we talk about the population, it refers to the total observation that can be made. A sample is a set of observations drawn from a population. Normally, when we conduct experiments or interviews or surveys in a particular population, we just get the sample instead of the population, because in most cases interviewing the entire population would be very inefficient for the statistician. For example, if you'd like to know the average height of the people in a particular city, it's difficult for the statistician to interview all of the people in that city. What is normally done is we take samples. So we just select few members of that particular city and we take their height and we get the average. From there, we can draw conclusions about the population taken from the sample. And since we're taking just a sample, there are different ways on how we're going to get samples. So if there are like two statisticians, the sample of the first statistician may be different from the samples of the second statisticians, because they may interview different people. And with that in mind, that's where the sampling distribution of sample means comes in. There are a lot of ways that we can generate samples, and because of that, the mean that we're going to get from the sample would be different as well. So we'd like to know how are those sample means are distributed in that particular population. So before we have the sampling distribution, let's have some terms here. So we're going to use different terms to refer to the population and sample. We use capital N for the population size, and we use small letter n for the sample size. Take note of that. And we use the Greek letter mu to refer to the population mean, while we use this x bar here to refer to the sample mean. So we're going to use these variables extensively during the course of our discussion, so take note of the difference between the four. And for since we have a particular population and there are a lot of ways on how we're going to generate samples within that population. So in order for us to determine how many samples can be drawn from this population given a particular sample size, we make use of this particular formula. The formula is n taken n at a time. So this is a combination, population size taken sample size at a time. So n taken n, this is equal to n, population size factorial, all over n minus n, population minus sample, factorial, times the factorial of the sample size. From here, we can determine how many samples can be obtained from a given population size. So I hope you still remember this from your combinatorics. So let's have an example of how we're going to construct the sampling distribution of the sample means. Let's have here a population. It has 5, and the population size is 5. So take note of that. We have n is equal to 5 since the population is 5. The members are 12, 15, 18, 21, and 24. So we'd like to get the sampling distribution of the sample means of this particular population with a sample size of 2. So n equals 2. So we'd like to know the sampling distribution if the sample size is 2. So the first thing that we need to know is how many samples can we draw from this population. So we're going to make use of this formula. So n taken n, but the population size is 5 and the sample size is 2. So 5 taken 2 at a time. So this is equal to 5 factorial divided by n, capital population size is 5 minus sample size is 2 factorial times 2 factorial. So this will be our formula right there. So 5 taken 2 is equal to 5 factorial, all over 5 minus 2 factorial times 2 factorial. So this will be equal to 5 factorial. Remember that 5 factorial is 5 times 4 times 3 times 2 times 1. And 5 minus 2 is 3. So we're going to end up with 5 factorial divided by 3 factorial times 2 factorial. So we have that. Let's fix this one. Right there. So align, yes. So remember that 5 factorial is 5 times 4 times 3 factorial. I'm going to leave it at 3 factorial since we have a 3 factorial in our denominator. And take note that we can cancel that, or we can divide rather. 3 factorial times 2 factorial is, remember, it's 2. So from here, we get to cancel this 3 factorial here. So we're left with 5 times 4, and 2 factorial is equal to 2. So we have 5 times 4 divided by 2 factorial is 2. So 5 times 4 divided by 2. So this would be equal to 5 times 4 is 20 divided by 2, that is 10. So we are left with 10. Therefore, this means that we can draw 10 samples from this population here, and that's what we're going to do. Let's take the 10 samples right now. So let's make a table. So we're going to do two things here. First, we're going to draw samples from this population. So let's look at the population right here. It's this one, 12, 15, 18, 21, 24. And on this one, we're going to get the sample means. So here's the sample. Wait, let me center all of this first. Right here. First, we'd like to get the sample and the sample means. The sample first and the sample means. So let's take two scores at a time. So we have 12 and 15. We also have 12 and 18, 12 and 21. We're going to take all possible combinations of taking two scores from this population of 5. So 12, 21. We also have 12, 24. We also have 15, 18, 15, 21, 15, and 24. We have 18, 21, 18, 24. And lastly, we have 21, 24. So we have the possible samples of this particular population here. Let's now get the sample means. So let's bring out our calculator here, and what we're going to do is we're going to get the mean of each sample. So basically, we're going to get the average. So add them, divide by how many samples are there. So that's how many members in each sample rather. So there's 2. So we just get 12 plus 15, that's 27, divided by 2, that is 13.5. We're going to do this for all of the samples. So we have 12 plus 18 divided by 2, that's 15. Also have 12 plus 21 divided by 2, that is 16.5. Next we have 12 plus 24 divided by 2, that is 18. For 15 and 18, 15 plus 18 divided by 2, that is 16.5. Next, we have 15 plus 21 divided by 2, that is 18. Also have 15 plus 24 divided by 2, that's 19.5. 18 and 21, that's 18 plus 21 divided by 2 is 19.5. We also have 18 plus 24 divided by 2, that's 21. And 21 plus 24 divided by 2, that is 22.5. Next, what we're going to do is we're going to construct now the sampling distribution of the sample mean. So let me just remove this split screen here. So there's the sample means, and take note that there are sample means which are repeated, like the 16.5, like the 19.5, and 18 right here. So what we're going to do is we're going to construct another table. Let's have another table. Or let's have it on the other side instead. Right here, let's insert a table here. So like there, like that one. So we have here, let's center this one. we have here first the sample means, and next is the probability. So what are the sample means that we have? We have 13.5, we have 15, we have 16.5, we have 18, we have 19.5, we have 21, and we have 22.5. So what we're going to do is we're going to check how often did this sample mean appeared out of how many times. Let's look at 13.5. This 13.5 here in our sample means it appeared only once out of 10 times. So the probability is 1 out of 10 times. So 1 over 10. So let's have the layout in the middle here. So 15 appeared only once out of 10 times, so the probability is 1 out of 10. 16.5 appeared twice, here and here. So the probability is 2 out of 10, or simply 1 over 5. Remember this 2 out of 10, simplifying 2 out of 10 is 1 over 5. We also have 18 right here. 18 appeared twice as well. So the probability is 2 out of 10, or simply 1 out of 5. So 1 over 5. 19.5 appeared twice. So that's 2 out of 10, or just simply 1 over 5. We're just simplifying the fraction. 21 appeared only once. So the probability is 1 out of 10. And 22.5 appeared only once again. So that's 1 out of 10. So here's the sampling distribution of the sample means. This table right here is actually the sampling distribution of the sample means. So here's the sample means. Here's the probability of its occurrence. So basically, we are looking at the probability of the means of the sample. Take note that in every time we draw samples, there is a different mean. And the probability of getting those means is listed down on the sampling distribution of the sample means. This comes in handy later on when we take the mean, the standard deviation, and the variance of the sample means, which will be covered in our next video. So I hope you guys learned a lot today. Thank you guys for watching, and see you guys in the next video.